Okay, so hi there everybody. We're now in our next video on college algebra. In this video, this is the next video about algebraic fractions, and we have talked about how to reduce algebraic fractions in the previous video. Now we're going to talk about the least common multiple, the LCM, for this time, algebraic expressions. We have talked about the LCM for pretty much in all sorts of playlists that we have done, the fundamentals of mathematics, we have talked about it, and also in the number theory, if you want a more grounded um, formal definition of least common multiple, so better check my number theory playlist. But now we're going to talk about the LCM in using algebraic expressions, or how it will apply with algebraic expressions, that is with variables. So before we start off with variables, let's have a little bit of review, shall we have? How to get the LCM, okay, of integers. So what is the least common multiple of 4, 10, and 15? Okay, so what is the least common multiple of 4, 10, and 15? So if you can remember it right, how do we do this? Um, First, we write this as a solution. Okay, let's put it here. Solution. Um, how do we do this? We write the 4, we write the 10, we write the 15, we prime factorize them. Remember, so 2 times 2, 10 is 2 times 5, put 5 here. 15 is 3 times 5, so 3 times 5. So how do we get the LTM of 4, 10, and 15? So we better first encircle, or take note of the common values. So 2 is common in 4 and 10, 5 is common with 3 and or 10 and 15, so 5 is common there. So what we're going to do is we're going to multiply all the numbers. We're going to take these common numbers once, so let's put first the common 2, let's put the second 2, let's put the 3, and let's put the 5. So what will it be? So 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60, and this is the LCM. Okay, this is the LCM of 4, 10, and 15, 60. Okay, now for the second number, how about if we are asked to find the LCM of x squared y z cubed, x squared y squared, and x cubed y z squared? Okay, so again, just to give you a definition of the least common multiple in algebraic expressions. So the LCM of a given set of expressions is the smallest expression which is exactly divisible by all the members of the set given. Okay, it is the product of the different prime factors that appear in any of the expressions, each with an exponent equal to the largest exponent with which the factors appear. So if you want the same old solution, just like the ones we have shown above, so it will look like this. X squared y z cubed, we have x squared y squared, and we have x cubed y z cubed. So if we're going to write that one by one, this is x times y times z times z times z. This is equal to x times y, and this is equal to x times y times z times z times z. So that's pretty tedious to do, but okay, I'll show you how this works. We have all the x's, common x's. This one doesn't have any common x, so let it be. We have the common y's. We have only one common y, and we have the z's, which are common, so also common also, z and the z. Okay, so yeah, pretty much this is it. And then what we're gonna do is count them all. So we have what's the LCM rather. LCD works for the denominators. So XX and triple X. So okay, X times X times X. Okay, and then we have two Y's, this one and this one, Y times Y. And then we have three Z's, Z times Z times Z. So what is it? Let's summarize this. So we have X cubed Y squared Z cubed. And this is our answer. Okay, you want a shortcut? Here it goes. The largest exponent in which x appears is 3. That's x cubed. That's the largest exponent with x. The largest exponent with y appears is 2. That's y squared. And the largest exponent in which z appears is 3, z cubed. And then copy them off. X squared, y squared, z cubed. That's our answer. Actually. Okay, again, if you're given simply, okay, monomials, just look at their highest exponent and then combine them. So the highest exponent for the x's is 3, x cubed. Highest exponent for the y is y squared. Highest exponent for the z is z cubed. So we have just combine them, put them in one term, a single term. Okay, so that's a shortcut. That's the shortcut. And why did that happen? Just look at this process if you want. Okay, that's the process. And then let's go to number 3. Let's go to number 3 now. Now for number 3, here it goes. And then we're going to apply some factorization along the way. So number 3, find the LCM, the least common multiple of a squared minus 4b squared, a squared minus 4ab plus 4b squared, and ax plus 2bx. So let's write the solution for this solution. So we're going to write them first one by one. So we have a squared minus 4b squared minus. We have a squared minus 4ab plus 4b squared. And we have ax plus 2bx. Now, instead of factorizing them, okay, again, instead of prime factorizing them, we need to factorize them, okay, as the procedures that we have talked about in the previous videos, like the difference of two squares, common monomial factoring, quadratic trinomials. We need to recall those things. Again, I have emphasized that we will be using that in the future. And here it goes. What factoring procedure can be used in this first expression? Okay, maybe you can pause the video to think about that. And you will see that we can use the difference of two squares here. This is a square, a perfect square, a squared. This is also a perfect square, 4b squared, and we have a difference of them. So we will use the difference of these two squares. So that's the OTS. So how do we use that? This is going to be get the square root, 2b, correct? A 2b, and then put a minus here, put a plus here. It doesn't matter. You can put plus here and then minus here. That by the commutativity, they're still the same. And then what? Let's how about this? What factorization method can be used in this second term? Maybe you can think of that for now. And not long you will think that we can apply the perfect square trinomial here. Since this is a perfect square, this is a perfect square. Combine them and get the square root of them. We have a and we have 2b. Okay, 2ab. Okay, multiply that by 2, and we have 4ab. 4ab. Okay, so since it's 4ab, meaning it's affirmative that it is the perfect square trinomial, only that notice it's a minus sign here, so it's going to be a minus sign in between. So get the square root of this, get the square root of this, 2b minus, put a square. Okay, that's it. And then for the last term, how about this? I think it's very trivial to say that we will be applying the common monomial factoring. We're going to get the common factor, which is x, and we have a plus 2b. And then pretty much we're going to apply the one that we did in the previous examples. Maybe we can make it better for the second one. Not put a square there. Instead, let's put a minus 2b. Okay, so that we can do the box thingy. And then we'll box the common things. This is common for both two. And then a plus 2b is also common for these two here. So we're going to write that once. And yeah, so how many terms do we have? We have this box here. We have this box here. We have this single term. We have this single term. So we have pretty much four factors. And then for the LCM, what do we have? We have a minus 2b. We have two of them, so maybe you can put square instead of writing this again. We have a plus 2b. We're going to write it once, and we have x. Yeah, and then yeah, pretty much that's the answer. If you want to rearrange it in whatever form you want, maybe you want to put the x first, and then a plus 2b, and then a minus 2b, oops, 2b quantity squared. So it's pretty much the same by commutativity. In multiplication, they're still the same. So yeah, that's our video for the LCM, the least common multiple for algebraic expressions. I hope you learned something from this video. And yeah, thank you very much for watching. Don't forget to hit like, and click the subscribe button, will you? Thank you very much, and see you soon.